in the last problem, we were finding a general solution. But in this problem, we're going to solve an initial value problem, which means they're giving us an initial conditions as well as a differential equation right here, or diff-EQ. All right, so let's see here. We want to find the first derivative just to start with. So remember that y prime of t would be equal to the integral of y double prime of t dt. Right? That's the fundamental theorem of calculus. So then I'm going to take the integral of t e to the t dt. Well, it's been a while since we've seen one of these. This is going to involve integration by parts. So we would want to let u equal to t. So let me remind everybody. The integral of u dv is equal to uv minus the integral of v du, right? That's the integration by parts. It's been a while. All right, so I'm going to let u equal t. And then du would be equal to dt, right? And then dv is equal to e to the t dt. And so therefore v is equal to the integral of that, which is e to the t. There, I changed it to green just to make it a little bit easier to read. Okay, so now I want to do u times v. So that would be t times e to the t. T times e to the t. So this is equal to t times e to the t minus the integral of v du. So v is e to the t. Du would be dt. Like that. Oh, okay, but we know what the integral of e to the t is. The integral of e to the t is e to the t. We just did it over here. That's why we love e to the t. So this means that y prime is equal to t e to the t minus e to the t plus a constant. I'll call it C1. All right, now this is a general solution for y prime. Okay. But I don't want a general solution, I want a particular solution. So I can use the fact that I know that y prime of 0 is equal to 1. So use y prime of 0 equals 1 to solve for c. Find C1, right? That's what you're using. Oh, that should be a colon. All right, use y prime of 0 equals C1. All right, so y prime of 0 equals 1. So that means that 1 is equal to 0 times e to the 0 minus e to the 0 plus C1. So that's 1 equals, that's 0. So that's gone. Don't have to worry about that. Minus, well, e to the 0 is 1. So minus 1, or if you like 0, take away 1 plus C1. We add 1 to both sides, and lo and behold, C1 is equal to 2. So putting all of this together, I know that y prime of t is equal to t e to the t minus e to the t plus 2. I'm not boxing that because, of course, that's not the actual answer. That's the particular solution for y prime. But I actually want the particular solution for y. So I have to do it all again. All right, let's switch colors, make things a little bit easier. Okay, so y of t would be equal to the integral of y prime of t dt, thanks to the fundamental theorem of calculus. So that's equal to the integral of t e to the t minus e to the t plus 2. Now I don't have to do this all over again. We already saw how this works, seen above. It would use integration by parts, and we already know how that's going to go. So we're just going to do it. It's going to be t e to the t minus e to the t, right? So this part, it will be, I'll just write it, t e to the t minus e to the t. Then minus another e to the t, because the integral of e to the t is e to the t, plus 2t, because we integrate that. Oh, I forgot my dt back here. My goodness. And then plus a new constant, c2. Interesting. Okay, so I can clean this up in a second, but I do know that y of, I mean, this works as a general solution. It's not cleaned up because these two are like terms, but it's still a general solution. So now I could find C2. To find C2, I'm going to use that y of 0 equals 0. All right, so y of 0 would be equal to 0 times e to the 0 minus e to the 0 minus e to the 0 plus 2 times 0 plus c2, and the whole thing has to be equal to 0. All right, well, that's 0, that's 0, so those are gone. These are each 1, right? So it's really minus 1 plus c2 equals 0. So I would add these two over to the other side, and c2 is equal to 2. Therefore, y of t is equal to, my actual particular solution would be t e to the t minus, and I'm going to combine these two together now and make a minus 2e to the t. So these two are going to go together and make minus 2e to the t because they're like terms. Plus 2t plus 2. That is the particular solution. For y that was being asked for.